Lesson 15, the distance from a point to a line. A long time ago we talked about having a line and a point, and the shortest distance from that point to that line was a perpendicular line. I believe the lesson went something like, I've got a car driving down the road, and a person on a sidewalk. This is a hat, not hair. And music playing, maybe? And that person, you know, the music sounds really far away, but when the car is directly perpendicular to that person, the music is the loudest. I believe so, and I think there are also people making fun of my ability to draw, which totally makes sense because my ability to draw isn't all that good. So that's what we're talking about today, again. So let's just go straight into an exercise. A robot is moving along a line, 20x plus 30y equals 600. A homing beacon sits at the point 3540. Where on this line will the robot hear the loudest ping? I'll erase this line in a second, but I have a line and a homing beacon. So a line and a homing beacon. Okay, this is just like the cars and the person. You know, the robot is moving along the line and a homing beacon sits right here. Where on this line will the robot hear the loudest ping? Well, the loudest ping isn't going to be when the robot's way far away or way far away. The loudest ping is going to be where the robot is directly perpendicular to the homing beacon. Okay, it's the shortest distance between the homing beacon and the robot is a line perpendicular. Okay, but let me erase this so that we can start working on this problem. So we need to determine the equation of the line passing through the point and this line. So if I know the slope of this line, if I find m, I know the slope of this line will be perpendicular. So let's just find the slope of that line. 20x plus 30y equals 600. I'm going to subtract 20x from both sides. Negative 20x plus, 600. And then I'm going to divide everything by 30. Y equals negative 20 over 30x plus 200. Nope, plus 40. Let's try to get it right. 600 divided by 30 is 20. Nothing like scribbling out your work. So the slope of the robot line is negative 2/3. Therefore, the slope between the beacon and the robot line, so remember we have a robot line and the beacon, well, this slope is negative 2/3. That's a negative. Negative 2/3. The slope of this, the line between the beacon and the robot, is going to be perpendicular. So positive 3/2. So we need to determine the equation of the line passing through the point, 3540, that's perpendicular to the robot line. So I've got the slope and I have a point. So let's just use the point slope form. Y minus 40 equals 3/2 x minus 35. I'm going to multiply everything by 2. To cancel that out, I have x minus 35 times 3 equals 2y minus 80. 2y minus 80 equals, distribute the 3, 70 plus 35 is 105. Now I'm nervous. Let's check my math. Yep, 105. Add 80 to both sides. Negative 105 plus 80, 25. And divide everything by 2. There we go. Where on this line will the robot hear the loudest ping? So it's where these 2 points intersect. So I just came up with the equation, we'll keep it in red, of this line, which is right here. That's between the homing beacon and the robot. And this line, which is the robot. So where on this line will the robot hear the loudest ping? He'll hear it right at that point, right there. So there's a variety of methods for you guys to determine the point where the 2 lines intersect. Substitution is probably the easiest way. So I'm going to grab this equation right here and plug it in for y on that equation, but I'm going to do it on a new slide. So 20x plus 30y equals 600. I'm going to substitute 20x plus 30, and then y equals 3/2 x minus 25 over 2 equals 600. Do a little magic here. Let's solve for x. You guys can watch. Let's see. 30 times 3 is 90. Divided by 2 is 45. Minus, so I'm distributing 25 times 30 divided by 2, 375 equals 600. So I have 65x equals, 975, x equals 15. Go ahead and plug that into any equation to get y. I keep forgetting that 0 on the 600. Sorry. So 30y equals 300, y equals 10. So those 2 lines, the robot line and the beacon perpendicular line, intersect at this here point. Okay, the robot will be the closest to the beacon when it is on the point 15, 10. At this point, how far will the robot be from the beacon? Okay, so what's our distance? We've got the beacon is at 35, 40. And the closest distance to the robot was 15, 10. That's the good old-fashioned distance formula. 35 minus 15 squared plus 40 minus 10 squared. $1,300, which is square root 1,300. 36.1 units. Cool? Cool. So everything we did so far is stuff that you guys have done before. What we're going to work into now is this crazy equation that can find distance between 2 points, or distance between a point and a line. Okay, and there's this really long, like 2-page proof in the teacher's manual that we are not going to go through because that just doesn't seem to make sense at all. but we are going to try this new distance formula just to see how it works. You can choose to use it or not. If you don't use it, you're going to have to find an equation of the perpendicular line and the distance between 2 points. If you choose to use it, it's pretty awesome and does make things a lot easier. So let me set some things up for you guys. So your equations that you use are always going to have to be in this form. You're going to have slope-intercept form for your line, which is y equals mx plus b, and then the point that is going to be closest to the line, which is going to be pq. Your x value is p, your y value is q. Because if you look here, you have p, q, m, which is slope, b, which is y-intercept, m squared, p, which is your point, you know, p, q, slope, b, y-intercept, m, slope, m squared, y-intercept, and q. So this looks really daunting, but this is all you're messing with. You're just replacing and calculating, right? That's not too bad. Let's try this first one, which is really simple. It's going to be 0.00 and y equals 10. So in this case, when my line is a y value, that means it's horizontal, and my slope is 0, because horizontal and 0 both have z's in them. And my y-intercept is 10. Okay? P is 0 and Q is 0. That's right here, P and Q. So my distance is a big, long radical with lots of stuff going on the inside. So I'm going to replace all of the letters up here with numbers, mostly zeros. P plus Q times M minus B times M all over 1 plus M squared minus P, quantity squared, plus M times P plus Q times M minus B times M all over 1 plus M squared plus B minus Q quantity squared. The proof was honestly 2 pages long. Okay, let's simplify the first parentheses. I have 0, 0, 0 over 1, which is 0. That's 0 squared. Plus this whole thing is multiplied by 0. Plus 10 minus 0. Plus 10 squared. So the square root of 10 squared is, in fact, 10. Interesting first one to try, right? Where everything goes away and my distance is 10. If I look at it though, we're doing 0.00 and a line y equals 10. Goodness. So a line y equals 10. The distance between that line and the point would be the perpendicular line, which is 10 units away. Makes sense. Okay, let's try a different one. We're still at the origin, and we have a line y equals x plus 10. So here my slope is 1. All that means is I'm crossing the x or the y-axis at 10. I have a slope of 1. How far is the origin away, which would be a perpendicular line right there, right? Okay, so let's try it. And again, if you graphed this one, you could probably use Pythagorean theorem and come up with it super fast. But let's try this fun equation, because I've never used this fun equation before. It's sort of exciting, something new. I like learning new things too. It's a really long radical. Okay, we have, where's my, there we go, P. Sorry, P equals 0, Q equals 0, M equals 1, and D equals 10. So P plus Q times M, I did the Q again. So supposed to use numbers, not letters. Q times M, ha! I hope you guys are enjoying this. Minus B times M, all over 1 plus M squared. Quantity squared plus m times p plus q times m minus b times m all over 1 plus m squared plus b minus q squared. This right here simplifies. Got 0, 0. 10 divided by 2 is 5. Squared is 25. And then, let's see, 0, 0 minus 10 over 2 is negative. I should put that was a negative 2. Negative 5. That'd be negative 10 over 2 is negative 5 squared. Nope. My square is in a different spot. So let's get it right. Negative 10 over 2 plus 10 squared. That is negative 5 plus 10 is 5. Squared is 25. So we are at the square root of 50. Square root of 50 is 5. Square root, oh, clear. 7.1 units. Sort of fun. Let's see, that's another 0.00. I'd rather do something harder. Let's see, and that's 0.002. Oh, your homework is -21. We're going to do another, well, I'm going to give you the answer to this one because I don't think we need to do another point or another origin. I think you guys got it. I'm here, my slope is going to be 1 and my y-intercept is -6. P is 0, Q is 0. Okay, I'll help you on your problem set. There's only one there, so I don't want to do that one either. I need you to practice on one using this method if you feel like it. But you can ask me questions when you get to that one on your problem set. That's it for today. Good job.